Hello everyone. My name is Jenny Gardner and I'm one of the math coaches here at SNHU. Welcome to Academic Support's Guide on Confidence Intervals. Today we're going to start with definitions, then we'll go over an example with means, and finally another example with proportions. So definitions. What is a confidence interval? So there's an official definition I'm going to put up here. It's a calculation that determines an interval that contains the true value, a mean, a proportion, or something else. But basically, we have a sample, and we want to relate that sample to a big population. The population is whatever we're focused on for our particular studies or research. So I'm going to make this box represent the population. And from within here, we had a whole bunch of people gather. These are the dots, and they make up our sample. But they're not everybody in the whole population. There's people outside of it. So this sample is just a smaller group of the population. And there's requirements for every sample for us to be able to run a test, and you should definitely brush up on those requirements. But when we have a sample, we want to be able to talk about the whole population. And in order to do that, we make a confidence interval or do some other things. But in this case, we're going to talk about confidence intervals. So if we want to talk about the true value in a population, we take a sample and then we have to think, well, the sample number, the one number that we get, the mean or the proportion, that isn't necessarily an exact value. There's got to be some leeway surrounding it. And so we sort of build a buffer. So we have in the middle, down here, we have our point estimate. The point that we're talking about, that we're estimating, the mean, which would be x bar, the proportion, which would be p hat, whatever we're working with at the time. But it's this point that we're estimating from the sample. So in order for us to talk about the population, we add the margin of error and subtract the margin of error from that value, and that gives us 2 points. An interval of a lower number and an upper number to describe the whole population, and say the true value is within that lower and that upper with some % confidence. So the margin of error itself is a calculation. It has its own special formula, and that is different depending on what you're working with. But what it is every time is going to be a critical value of some sort, depending on your distribution, a critical value multiplied by the standard error. But the critical value depends on what distribution you are using, and the standard error depends on if you're working with a mean or a proportion or something else. So this is what the margin of error is, but we need to get more specific with our values so that we can put symbols in there and then therefore put real numbers in to solve. But overall, whatever our point estimate is, whether it's x bar or p hat or something else, we're going to add and subtract the margin of error to it to find our confidence interval. 2 numbers makes the interval. So we're going to try this out. I have some data, I have Excel, I have the formulas, and we're going to work through this. Remember, you can pause at any time. Anytime that you want to try this yourself, pause. All right, for every single confidence interval, you ask yourself, what is my level of confidence? What type of problem is this? And what is our margin of error for this problem? 3 questions: level of confidence, type of problem, margin of error. Now, sometimes your level of confidence is given if you're working on a word problem or a school homework. If in research, you have to make your own. But I'm going to pick 95%. I like 95% confidence because it's not too high and it's not too low. It's not 99% confident. That's very close to 100. You don't want to be too confident. That gives you more error. And if you're too low, then you're not going to have as substantial of results. You want to just have a good amount. So a lot of people use 90, 95, or 99, and I'm going to choose 95. So I'm going to be 95% confident here in the problem I'm going to do. That's the one I chose. So I want to do a 95% confidence interval. What type of problem is this? Well, if you look at the symbol here, I wrote the mu symbol, and that should actually be X bar and not mu, so let's cross that out. There we go, X bar. And I also wrote two formulas. So on the left, it says T alpha. On the right, it says Z alpha. So on the left, we're using a T distribution. And on the right, we're using the normal distribution. When thinking about which distribution to use, you have to think about what you know about the population. So I'm going to show you both, but I want you to investigate that further. Go look up what the difference is between the T distribution and the normal distribution. That's going to help you understand this further. I'm going to see if I can make this bigger to get rid of this. I'm going to get rid of that. Okay, so now we know 95%, we know it's a mean, and we know that these formulas represent two different distributions, but this side is the margin of error. So what is our formula for margin of error? It's the critical value multiplied by the standard error, and that formula S divided by the square root of n is our standard error. And this is just a reminder that this needs to be X bar. There's a symbol sheet, and you should definitely look for that in our video description as well. So we're going to try this out with ages of concert attendees. So I included a bunch of different ages of people who attended a concert, right here, a sample of people who attended a concert. And from there, I got the descriptive statistics. Now remember, descriptive statistics, there is a video about this as well. Check the video description. It can be found under the data analysis tool, and you can get your descriptive statistics there. We have it all set up here so that we can solve this. So for this, I'm going to need, for my formula said that we would need X bar, that we would need standard deviation, that we would need n, and finally, that we would need the critical value, and I told you I would tell you how to get it for t and for the z normal distribution. So we're going to go over all of that and finding that, some of which we already have right here, because the whole reason we're doing that is so we can do the formula. I'm going to write the formula for the margin of error. So this will be the margin of error, okay, because the margin of error is going to equal the critical value times standard deviation divided by the square root of n. So this is the formula I need to do for a margin of error. And so to do that, I have to first, put the values in. So those are the different things I need, and we'll figure that out and we'll be able to do that. X bar is the sample mean. Well, this was the sample, and this is the mean that came from the sample. So this is, in fact, X bar. So I'm just going to copy and paste. Control C, Control V. Control C like cat, Control V like violin. Standard deviation is right here. Control C like cat, Control V like violin. And n is all the way down here at count. There were 16 numbers in this column, 16 values. That is my n. I'm going to hit V there, and I have copied and pasted all 3 values that I needed there. This does not include the critical values. We have to find those on our own. So equals T dot inv is how we're going to do the T one. So it says probability and degrees of freedom. So it says probability first. In the confidence interval, we said we were doing 95%. So we were doing a 95% confidence interval. And we're going to get 2 numbers that contain 95% in the center. But there's some leftover on either side because there's 100% total and 95 is in the middle. So if we take 100 minus 95, that leaves 5% left over. That's also called alpha. That's the leftover bit. 95 and 5 make 100. But on each side, we have to split it. So 5% divided by 2 means that there is a 2.5% on either side. That's the probability. That's the probability that we need. So we need to know for 2.5% probability, what is the critical value T and the critical value Z? So 2.5%, remember that would be written as 0.025. And if you're ever in doubt, divide by 100. 2.5 divided by 100, 0.025. Okay, so now we know that. So let's go back up here. Equals T dot inverse INV. Probability, 0.025. Degrees of freedom. Well, degrees of freedom, we're just going to take our sample size and subtract 1. So instead of 16, we'll write 15. So you'll notice it says J12. That's just because that's where I clicked because I had written it in here. You could also just type 0.025, whatever you want. Okay, I'm just going to click it though, because then if I wanted to come back to this, I could just change that probability if I changed my confidence and I would be able to get another one. So I like to have things made easy for me for later. So when I hit enter, I'm going to get my critical value. That's a negative. Well, that's because it's on 2 sides. And so therefore, because the distribution is symmetric, it's going to be both negative and positive. So we just want to focus on the number. So right here, I'm going to say equals 0 minus this number and get the same exact thing. Equals 0 minus the number gets the positive version. So we have the critical value for T. But we also need the critical value for Z. And this one is equals norm dot S dot inverse. For the standard normal Z, we need norm dot S dot inverse. And it asks you to enter the probability. Well, we already have that. It's still 0.025. Our confidence didn't change. Once again, it's the negative, and we want to make sure we have the positive, so equals 0 minus this number. And so now we have everything we need to create this confidence interval. Okay, so this is the formula for margin of error. Equals the critical value times standard deviation divided by the square root of n. It's all right here. Equals the critical value times the standard deviation divided by SQRT, that's the square root of n. Now you can put parentheses around just to make sure things come out correctly. But as long as you've clicked the correct things and put everything in correctly and have the formula right, when I hit enter, I'm going to get my margin of error based on the critical value. So this is my margin of error solved right here with the T. Let's find the margin of error for Z. Okay, so this equals Now this is the Z critical value times the standard deviation divided by SQRT for square root of N. And I hit enter. And now I see there are two different margins of error. One for T and one for Z. So to find my final answer of my confidence interval, my lower and my upper and my lower and my upper, I have to take this margin for error and add it and subtract it from the mean. So the lower equals X bar minus, because it's lower, minus the margin for error, equals X bar plus the margin for error. And that's my first confidence interval with T distribution. And this one equals X bar minus the margin for error. Every time I'm just hitting enter. Equals X bar plus Z margin for error. And I have a different value set there. So you see they're not going to be the same. The Z distribution is going to give you a different value. Even though you had the same standard deviation and the same N, the margin matters too. Which distribution you're measuring with matters too. Okay, so I am 95% confident that the true mean lies between ... It lies between 21.36, 21.37 if I round, and 25.88 for the T distribution. And that's the one I would probably end up using because I didn't know anything about the population standard deviation or anything. So I would probably go with the T for the unknown. But you could use the Z, and you will use the Z in your different problems in your different courses. So when you're looking through, just make sure to know that they are different and make sure to know which one you're using at any given time. But that's how to calculate with them. And finally, proportion is very, very similar. We have this lovely formula here, almost exactly the same here, but it has a different value here. So if I was going to do this, I don't need data necessarily. Instead, I just need an X value and an N value. X being the number of like yeses or responses out of the total. So if I wanted to know, if I did a survey about how many people drink water in a given day, and 75 out of 90 people drank water, then 75 are the yeses and 90 is my total. So when I have P hat with that little triangle on top, it's going to equal the number of yeses divided by the total. So 0.83, about 83% drank water that day. But we want a confidence interval. We want to have a lower and an upper. So to do that, we still need to do the rest of the formula. The margin of error is important. So remember the formula that I just showed over here on the PowerPoint, I'll pull it up again, is the critical value times this lovely different standard error. So this one we'll have to put in for the calculation. It's the square root of P times 1 minus P divided by N. And that's multiplied by the critical value. In this case, it's the critical value Z, the one from the normal distribution, because that's the one we're going to use for a proportion. So we have this big part here that we'll calculate. So we have P hat right here, N we have is 90, and so we just need critical value Z. Well, guess what? That didn't change from 95% over here, so we still have that critical value. So let's just copy it over. I want to remind you, you can pause at any time. I'm going to go 1.96. I'm going to round it, okay? All right, so we have for this one equals the critical value times SQRT for square root of p hat times 1 minus p hat, get to click it again, divided by n, the sample size. Close off our parentheses, and this is going to give us our margin of error. So this calculation is very straightforward, not too much to find. You just needed p hat and the critical value and n. And we have this lovely number here. So our full confidence interval is going to equal p hat minus that number and equal p hat plus this number. So I am 95% confident that the true proportion of people who drink water is between 0.75 and 0.91, 0.76 for rounding. So looking at this, this gives us something to discuss for the whole population. And we're confident that the true proportion is between there. So this formula is for proportions, and when you're working with one number out of another, this is the one to use, versus the one for means we looked at before. Way to go, you have made it through. But remember, at any point during this, you can pause, which means you can go back and rewatch any part that was confusing you, and skip the ones that you understand. You can do that with any video. Congratulations, you have made it through and conquered our confidence intervals video today. Thank you for watching our academic support guide on confidence intervals. And please read the video description for further video resources and other resources that you might find useful. Have a wonderful, wonderful day.